Hello everyone, welcome to Drishti CUET and welcome to your physics session. So today we are here with a very important topic, that is your current electricity. This topic is important not only for your CBSE board as well as in your CUET exam also you are going to get back-to-back questions related to current electricity. In this chapter you may get a numerical type question, you will also get like a factual or conceptual questions. So all the type of questions you will get it from this topic only. Okay, so here in this session related to current electricity, we are going to discuss a few topics, that is your electric current, right? First of all, we'll discuss what do you mean by electric current, right? Then conventional current, what is conventional current? Then we'll discuss about the drift velocity of electron, right? What do you mean by drift velocity? Then current density, Ohm's law, what do you mean by resistance, resistivity, conductivity, right? Temperature, how the resistance depending upon the temperature, what happens when temperature increases, decreases, how the resistance fluctuate. So we will discuss that also. Then color code for carbon resistor, it's a very small simple topic, so we'll just have a look. Series and parallel combination of a resistor, from which you will get numerical questions definitely, like in your class 10th also you have learned about the series and parallel, but they are the basic one. Here again in series and parallel you may get a numerical questions only, so you have to practice numeric formula, you have to practice the numericals, right? Then we will discuss with EMF, potential difference of a cell, internal resistance of a cell, and we'll also discuss the series and parallel combination of a cell. It's not like we have only these topic in this current electricity chapter, like we have remaining more topics, but today in this particular session we are going to discuss these topics. Alright, so let's begin the session with the introduction of your electric current, or you can say current electricity. Guys, before begin the concept of current electricity, I just want to let you know the brief knowledge about the charges, right? Because ultimately the charges are the one, right, which create the current, or you can say which create the current electricity. So as we know that we have matter, and matter is made up of electron, proton and neutrons, where neutrons are neutral whereas electron and protons are the negative and the positively charged particle. So if you talk about the charges, so whatever the charges we have two types of majorly charge, negative charge and the positive charge, right? The negative charge due to electron and the positive charge is due to proton. So basically two types of charges we have. Now these charges, everywhere we have a charges around us, because how everywhere we have a charges around us? Because we have a matter, like matter is something which has some mass and which occupies some volume. So even in the air also we have a gaseous molecule which is considered as a matter. So there also they have charges, right, within them. Now it's not like see, the charges are everywhere and the charges are stationary. Stationary means they are not moving here and there, they are just placed at their own position. So when these charges are stationary, right, they are not moving, they do not conduct electricity. Okay, now which type of charge conduct electricity? The charges which are flowing, right? So when the charge started moving, then it creates electricity. Until and unless the charges are at their own position, they are not moving, they do not conduct electricity. Okay, जब ये move करते हैं तभी electric current generate होता है. Is that clear everyone? So two type of charges we have, plus and minus, right? Now the charges when they move, they create electricity. In your electrostatic topic na, like that is your first chapter, electrostatic, there you will learn only about the charges. You only learn about the static charges, the charges which are stationary. Okay, and you are going to learn so many properties related to the charges, what are the what happened when the charge placed in this field, and like that, so many concepts you have there. Okay, but here in this chapter, now your charges started moving. Okay, so you can just understand like that कि charge का birth हुआ current electrostatic में, like you know about the charges, and then in current electricity in chapter number 2 of your NCERT, the charges started moving and conduct electricity. Okay, so how you are going to define electric current? Actually, the electric current is defined as the charge flowing through any section of the conductor in 1 second, right? So now what happened? Current is defined as the flow of charge in a conductor in 1 second. Like 1 second में कितना charge conductor में flow हुआ, that will tells you the current, that will defines the current. Okay, so current, always current symbol is I, and since I is what? Charge Q, charge is represented by Q. So the rate of flow, current is what? The rate of flow of charges, right? So this is charge and this is time. So in T second, Q charge flow and the electric current generated. Am I clear to everyone? So how you are going to define current? Current is nothing but the rate of change of current, rate of flow of charge, right? Simply rate. Whenever you talk about rate na, that rate always defined in the terms of टाइम. हमेशा रेट को हम टाइम के रिस्पेक्ट में बताते हैं. लाइक व्हाट इज द रेट ऑफ योर स्टडी? सो दैट मीन्स कि नाउ यू हैव स्टडी 3 hours per day. So that is the rate of your study. You studied 3 hours per day. So similarly, how much charge Q flow in 1 second or flow in T second, that defines the current. So I should be what? Q by T. Clear? Now this is the average one. I can also be written as dq by dt if the rate of flow of charge vary with time. So now dt, see what happened, it's not like like with dt, that is the instantaneous, this is the instantaneous current. At particular instant, how many charge is flowing, that can be calculated by dq by dt simply. ठीक है, that can be calculated by dq by dt, that at particular instant how much charge is flowing at particular time. Now electric current denoted by capital letter I. Okay, it flows. Now always the current flow from higher potential energy to lower potential energy. Now what is potential energy? See, we have learned two types of energy as well, kinetic energy and potential energy. Kinetic energy are those energy due to which any particle, any object moves. Okay, so whenever they are moving they have a kinetic energy, but when they are stationary at some height, then they have a potential energy. So similarly, whenever our charge in a static way, okay, like suppose this is our charges. Okay, so this is static na, it's not like कि by itself only the charge started moving. ऐसा तो होगा नहीं कि खुद से मूव कर ले. Here you can compare the Newton's law of motion, first law of motion. If any object is stationary, wants to remain in the stationary until and unless the external force applied on it. ठीक है, अगर कोई मूव कर रहा है तो वो मूव ही करता रह जाएगा until and unless an external force applied to stop them. So similarly, the charges, all the charges have their some of the potential energy they have na. right? So with that potential energy, they remain stationary, and when you applied an external force or external field, then what happened? They started moving. Clear? So here also, whenever the current, now current is what? The rate of flow of charge per unit time. Okay, so now if the charge is flowing, so obviously the potential energy changes, na? Right? Now how the potential energy changes? Like always the current move from higher potential energy to its lower potential energy, right? See, this is the symbol, this is the higher potential energy, this is the lower. So always current flow from higher potential energy to its lower potential energy. Right? SI unit of electric current is ampere. Ampere. How you are going to define ampere? 1 ampere is what? 1 coulomb charge flow in 1 second. This is how you are going to define ampere. Ampere is what? 1 coulomb charge flow in 1 second defines the 1 ampere. What is coulomb? Coulomb is the unit of charge. Clear? अभी समझ में आया? Electric current होता क्या है? Suppose I am having this conductor, here I am not getting any current. Why? Because the charges are just stationary, no external, no applied potential or no applied EMF is there, no battery is there, so no current is flowing. That's why I'm holding it very swiftly. Okay, but what happen if it is connected with some battery and generate some potential energy, and then what happened? They started moving. So when they started moving, current generated, and I am not going to hold it. Clear? So जब तक charge हमारे stationary हैं, they do not conduct electricity. When they move, conduct current. Okay? Formula current का क्या हो जाएगा? Q by T. I hope clear to everyone. Okay? Now we have a different types of current also. ठीक है? It's not like ना कि charges are moving in a steady direction only or in a one direction. So based on their movement, we have a different types of current. Now what are the types of current? Number one is your steady current. Here what happened? Which does not vary with time. Right? So now suppose this is the graph of your time and this is the graph of your current. So here what happened? Here the current generated, but the current is not varying with the time. Okay, same current is same with the time. Current is not varying continuously with the time. So this is what we called steady current. कि एक ही टाइप का करंट फ्लो हो रहा है. इट्स नॉट लाइक कि जैसे जैसे टाइम बढ़ रहा है वैसे वैसे करंट बढ़ रहा है. सो it does not vary with time. Now B and C. So here C, this is what? Steady current. Now B and C, what you have seen in B and C? In case of B, see here what happened? As the time increases, the current also increases. As the time increases, the current also increases. Here also the current increases, decreases, increases, decreases. So here it is known as varying current, whose magnitude vary with time. So this is your varying current, this is your steady current. Two types of current. Clear? In a steady current, the current is not like you can say the magnitude or the current is not changing, right, with respect to time. Here in varying current, only the magnitude, right, only the magnitude vary with the time. But now the third type of current we have is alternating current. Alternating current means what happened, guys? Whose magnitude vary continuously and direction change periodically. So see here, this is your alternating current. Here what happened? The magnitude also changing, direction also changing. This is positive direction, this is negative direction. Positive direction, negative direction. So as the time passes, what happened? The current magnitude also changes and the direction also changes. So this type of current is considered as alternating current. Clear? So 3 types of currents we have. Then we have a conventional current. Conventional current is what type of current? See, conventional current is the flow of electric charge from the positive terminal to the negative terminal of a power source. So conventional मतलब पहले के टाइम पे लोग क्या सोचते थे वैसा है. See, क्या एक सोच है करंट के लिए. See, this is the positive terminal, this is the negative terminal. So according to conventional current, what happened? Current always, the charges always move from positive to negative terminal, and in the same direction of charges. See, current is also flowing. So positive charges flowing from positive to negative, current also flowing from positive to negative. Right? It is the direction in which positive charge are assumed to move in a circuit, and this is the direction. Like suppose you have a circuit. Circuit कैसा होता है? Like suppose ये हमारी एक circuit है. This is the positive terminal, this is the negative terminal. So always the charge is also moving in this direction, positive charge also moving in this direction, and the current also is moving in this direction. So this happens in the circuit. Historically, like before the discovery of electron, जब तक electron की discovery नहीं हुई थी, all the scientists believe this phenomena of current. But once the electron discovered, now what happened? Electrons actually flow from negative to positive. तो जब इलेक्ट्रॉन की डिस्कवरी हुई, so what they got to know that electrons, since they are negatively charged, so they move towards the positive terminal, but current flow from positive to negative only. ये बात समझ में आई? Current flow from positive to negative terminal only. Electrons flow opposite to the current. ठीक है? पहले जब तक इलेक्ट्रॉन नहीं डिस्कवर हुआ था, दे थॉट कि पॉजिटिव चार्ज ही मूव करता है और उसी डायरेक्शन में करंट मूव कर रहा है. बट वंस द इलेक्ट्रॉन डिस्कवर्ड, दे गॉट टू नो कि नो, positive charge is not moving, electrons are moving from positive to negative terminal, right? Electrons from negative to positive terminal, but current moving in the same positive to negative one. तो वही same phenomena है current का, only what you have to remember that electrons flow in opposite the direction of current. This is what we called conventional current. Now thermal velocity of a free electron. So as I told you, the electrons, if the electrons are stationary, if the charges are stationary, they are not moving by themselves, right? You need to give an external energy or external force. Okay, so now thermal velocity, thermal is what? Temperature. Okay, so when you give, now and velocity is what? Velocity is displacement upon time, like how much distance covered, right, per unit time, that is the velocity. So here what happened? Thermal velocity is what? Like suppose this is your conductor and this has a electron. कंडक्टर है तो फ्री इलेक्ट्रॉन्स होंगे. जैसे ही आपने इसको हीट दिया, right, and you also know that in a conductor we have a free electrons. Okay, so free electrons in a metal move randomly with a very high speed of the order 10 to the power 5 meter per second, right, 5 meter per second. So now what happened? When you increase the temperature, right, the free electrons started moving at a very high speed, that is 10 to the power 5 meter per second की velocity से. Now the electrons are started moving, and this is called the thermal velocity. This velocity is called as a thermal. That means after getting temperature, when the electrons are moving with respect to time, right, that is known as thermal velocity. Now what happened? The average thermal velocity of free electron is remain 0. Why it remains 0? Because see what happened, when they gain temperature na, so all the electrons are randomly moving here and there, here and there. So what happened? Suppose this electron move in this direction, but this electron move in this direction. So they both cut each other, right? See, this moving in this moving, so they both cut each other. So ultimately, the average thermal velocity of free electron remain 0 because they are moving randomly, na? So few moves in this direction, few moves in this direction. So since they are moving in opposite direction, they cut each other. So average thermal velocity will be 0. Okay. Now let us understand the drift velocity. Okay. See, velocity अभी सबको समझ में आ गई है क्या होता है? Drift velocity is nothing but the how much distance covered by time, and thermal is after getting the temperature. Drift velocity is defined as the velocity with which free electron get drifted towards the positive terminal, right, under the effect of applied electric field. तो simple है, बहुत simple. Thermal velocity by applying temperature, heat. Okay. Drift velocity, when you place the conductor in electric field or on applying electric field in the conductor, right, then if the electron is moving from negative to positive terminal, right, that velocity in per unit time, that velocity is considered as drift velocity. तो simple definition है कि drift velocity में electric field के presence में electrons are moving. Okay. The free electrons get drifted towards the positive, since see here what happened. This is the battery, this is the positive, this long one is the positive terminal and this short one is the negative terminal. So here what happened, from the positive terminal, positive charge started coming and all the positive charge started accumulating here. Okay, all the positive charge started accumulating. In the metal we have a free electrons. So the free electron moves towards the negative charge and the electric field is towards this direction. Okay, why electric field is in this direction from positive? Like electric field का direction ऐसा क्यों है? See, when you learn electrostatic ना, there you will learn what? That we have a two type of charges, plus and the minus. So always from the positive charge, the electric field line goes outward. Okay, always from the positive charge, electric field line goes outward, right? And in the negative charges, what happened? The electric field goes inward, right? It goes inward. So due to this only, see here what happened. These are what? These are the electric field lines, right? These are the electric field lines which tells you the electric field, that each charges have a electric field around themselves. So due to this positive charge, जो electric field है किस direction में होगा? In this direction, and electron moving in opposite to the electric field, and in the same direction we have a current also. Clear? So electric field और current की direction same होगी and the direction of electron is opposite. Clear? So this is the drift velocity. Understood? Drift velocity. What happened? What is drift velocity? The velocity gained by an electron on moving from negative to positive terminal under an applying electric field. Simply, drift velocity is represented by V and small d. So this is the symbol of your drift velocity, right? Drift velocity is equal to A into tau. Now what is A and what is tau? A is the acceleration. What is acceleration? Change in velocity per unit time is the acceleration, right? In case of electric field, it is defined as small e, capital E, like charges multiply electron divided by mass, right? So here what happened? A is the acceleration. Now this tau is what? Tau is the relaxation time. What is this tau? tau is your relaxation time. What is this relaxation time? See what happened now. Suppose here we have electrons. Okay, here we have electrons. So when you applied the electric field, or when the temperature applied now, they started colliding with each other. They started colliding with each other. So the time taken from one electron to collide with other electron, that time is called the relaxation time. मतलब ऐसे समझिए कि एक पार्टिकल यहाँ है, एक पार्टिकल यहाँ है, तो इसको इसके साथ टकराने में जो टाइम लग रहा है, दैट इज कॉल्ड द रिलैक्सेशन टाउ. मतलब उस टाइम पे कोई कोलिजन नहीं हो रहा है, तो अभी रिलैक्स है, तो रिलैक्सेशन टाइम. ठीक है. सो एक पार्टिकल को दूसरे पार्टिकल से टकराने में, राइट, जितना समय लगता है, दैट इज द रिलैक्सेशन टाइम रिप्रेजेंटेड बाय टाउ. Now just try to write down this again. Acceleration is what? For electric field, acceleration is small e capital E by m. This is the acceleration in the case of electric field, where small e is what? Small e is the electronic, or you can say electron, charge of electron. Capital E is the electric field, and m is the mass of electron. So this is the acceleration, mass of electron, electrons and the electric field. Okay, so now write down the formula of acceleration here. Vd is equal to aem by m and the tau, right? Now what happened here? Again just try to open this formula. Okay, I is equal to what? N E A V D. Now A is what? Area of cross section. Okay, so this is the relationship between I and drift velocity. ये relation आपको याद रखना है. ठीक है, we have a derivation of this relation also, but for now just try to remember this relationship. What is the relationship between current and the drift velocity? So with this, what you will get to know, that current is directly proportional to the drift velocity. मतलब जितना ज़्यादा drift velocity होगी, उतना ज़्यादा current flow होगा. More the drift velocity, more the current flow. Now what is mobility, guys? Mobility is what? The drift velocity of electron per unit electric field applied, right? What is drift velocity? What is mobility? The drift velocity of electron per unit electric field applied is called mobility. Mobility मतलब होता है चलना, ठीक है? तो per unit में इलेक्ट्रिक फील्ड जैसे जैसे अप्लाई हो रहा है, so on applying electric field, how much electrons started moving, that is called the mobility. Okay, mobility represented by mu. Okay, and mu is what? Vd by E. So drift velocity per unit electric field. Okay, this is the mobility, right? Now its SI unit is meter square per second per volt. So this is the SI unit, meter square per second per volt, right? And its dimensional formula is what? M minus 1 T2A. So this is the dimensional formula. See, mostly like maybe you will get a question in CUET about dimension and all, but yes, in case of your board exam, you should know all these dimensions and units and all. Sometime you have to write down all the definitions and answers. So in that, you have to write down these formula and the SI units. Now current density. Okay, what is current density? Density का मतलब क्या होता है? Mass upon volume. Okay, current density is what? Current density at a point is within a conductor is the current through a unit area of a conductor around that point. Simply ऐसा समझिए कि like suppose this is your conductor. Okay, this is the conductor. Now this conductor is full of electron, free electron. Okay, this is full of free electron, and these electrons are moving in this particular direction. Okay, so what is current density, and when they move in this direction, the current is in this direction. Okay, and this conductor has some area, it has a cross sectional area. So current density at a point within a conductor is the current through a unit area of a conductor around that point. Now suppose we have taken this particular area. So how much charges are flowing, how many electrons are flowing in this particular area, right? And due to which how much current generated. So this is called current density. Current density represented by J. It is how much current is flowing per unit area. This is what we called current density. Like किसी per unit area में कितना current flow हो रहा है, that is the current density. Okay, current density represented by capital J and current flowing per unit area, right? Now here current का formula अभी हमने क्या देखा था, NEAVD. This is also the relationship between current and drift velocity. So how current density is represented with drift velocity? You can also write down J is equal to NEAVD by A. Just cut down. So ultimately what you will get, J is equal to NEVD, right? G is equal to NEVD. NEVD, where N is number of electron, E is charges, VD is drift velocity, right? This is the vector form. I is equal to J into J dot A is the vector form of current density. So just try to note down all these formula. Okay, the first thing what you have to do from the beginning only, right, whatever the topics you are covering, right, whatever the formula you are going to get, just make a list, current, electricity, whatever the formula you are going to get, just write down from the beginning onwards. Okay, that will help you at the end during your revision, because उस time पे फिर आप जब बनाने चलते हो ना, that will kills your time. तो at this point only try to write down those formula. Okay, this is one of the numerical from your NCERT in text book, right? NCERT का ही ये question है आपके in text. As you all know that for your CUET and for your CBSE, for both the exam, NCERT book only you have to prefer. Okay, so this is the in text question of NCERT. Estimate the average drift speed of conductor. Okay, average drift speed of conducting electron in a copper wire of cross section area. So here area is given 1.0 into 10 to the power minus 7 meter square, carrying a current 1.5 ampere. 1.5 ampere is the current. Assume that each copper atom contributes roughly 1 conduction electron, right? The density of copper is 9 into 10 to the power 3. So here the density is also given. How much? 9 into 10 to the power 3 kg meter cube. And its atomic mass is 63.5. So basically what you have to calculate here, the average drift speed. Don't read this question. Okay, what you have to calculate, the average drift speed you have to calculate. That means कि drift velocity आपको निकालनी है. So for that आपको drift velocity का formula पता है. What is the formula for drift velocity? I by NEA, right? How we will get this I by NEA? See, we know that I is equal to what? NEAVD. So यहाँ से हमने ये formula निकाल लिया I by NEA. Okay, because we have to calculate the drift velocity only. Electron is given 1.6 coulomb, area is given and the current is given. So here you have electron, area and current, everything is given. The density of conduction electron N is equal to the number of atom per cubic meter. So what is this N? N is the, small n is what? Number of atom, right, per cubic meter, right, per area में, per cubic meter में number of atoms, assuming one conduction electron copper atom as it's the valence electron. A cubic meter copper has mass itna, since 6.10 to the power 23 copper atom has mass 63.5 gram, it is given. So small n कितना हो जाएगा? This divided by this, multiply this. So ultimately small n you will get 8.5 into 10 to the power 28. Now you will get all the values, just try to put it down and you will get the answer 1.1 mm per second, right? So like this you may expect questions in your exam, so you have to practice such questions. Okay, for that just try to go through all the in-text question. Please practice all the NCERT in-text questions. Okay, then the another topic we have Ohm's law. So guys, Ohm's law, basically the electric current. What is Ohm's law? Ohm's basically the name of scientist, and this scientist gives you the relationship between the current and the potential difference, that is voltage. So voltage और current के बीच में relation बताया था Ohm's ने, ठीक है, and on the basis of that he just proposed a law. But the Ohm's law is only for a conductor only, ठीक है. Ohm's law किसके लिए है? कंडक्टर के लिए है. They are not applicable for insulator. Clear? So here what happened? According to Ohm's law, the electric current or the current is directly proportional to the voltage applied to the device, right? So the electric current flowing through a conductor is directly proportional to the potential difference across the two end of the conductor. Potential difference क्या होता है? Now suppose if you have two terminal, right, this is the positive terminal, this is the negative terminal. So this is higher potential, this is lower potential. So in between these you will get a potential difference, right, and that potential difference is represented by the capital V. Am I clear to everyone? We have a positive and we have a negative terminal, right? Positive and negative terminal, due to this they have a potential difference between them and you'll get capital V. So according to Ohm's law, the current is directly proportional to the potential difference, or you can also write down V is directly proportional to I. When you remove this proportionality, in place of proportionality you just write down R. So V is equal to R I. Now what is R here? R is resistance. R is resistance, right? So see this graph, this is V, this is current I. As you increase the voltage, since they are directly proportional, so as the potential difference increases between the two terminals, the flow of current, the current also increases in that conductor. तो जैसे जैसे आप potential difference बढ़ाते जाएंगे, current increase होता जाएगा. That is the graph says. Always they will give you straight line. Okay. Now what is resistance, guys, capital R is what? Resistance. Resistance is the obstacle between the flow of current, right? Like when you study, you have some of your friends who just distract you. Okay, let's go to party, let's go to movie, let's go to like outside, and any type of distraction. So your friends are your resistance. You are the current, you are studying, right? You are very good, but your friends distract you. So similarly, whenever in a conductor a current is flowing, so resistance will obstruct the flow of current. Okay. So the resistance of conductor is the opposition offered by conductor to the flow of electric current. So R, how you can write down R? See, V is equal to IR. So from here you can calculate R is equal to what? V by I. Okay. See, it is the property of conductor, like, or you can say any object. Suppose you have an insulator. So in case of insulator, the resistance is very high so that no current is flowing. So resistance agar ज़्यादा होगा, with this relation what do you get to know? If you have more resistance, less current flow. So here we have inversely proportional relationship between the resistance and the current. Okay. Now current ka formula we have already calculated, NEA VD. Okay. In place of VD we can also write down EEM by tau. Okay. Now this, what is this? EE by M tau. This is your VD na, because VD is equal to what? Area into tau. यही तो था ना हमारा VD. In place of A you can write down this value. अभी यहाँ से आप क्या करेंगे? N E square A tau M, right? And what is this E? E is nothing but the V by I only. Okay, so you have just write down V by I. Now just keep this M here, put this M here, and this value goes here, and V by I, write that. Now this V by I is equal to R. So from here what you will get? You will get the value of resistance, right? यहाँ से हमें क्या मिल गया? Resistance की value मिल गई. Now this R is equal to rho L by A, where rho is M, N squared tau is the resistivity. So this is again the formula of your resistance. Here with the resistance, guys, what you will get to know, that resistance is directly proportional to the length. See here, the resistance is, this is what? This is L. Resistance is directly proportional to L and inversely proportional to area of cross section. That means as long as the length of the conductor, मतलब कोई वायर जितनी लंबी होगी, okay, more the wire, more the length of the wire, more the resistance. ठीक है, जितना लंबा वायर होगा उसमें उतना ज्यादा रेजिस्टेंस होगा. मोर द रेजिस्टेंस, लेस द करंट. क्लियर? सिमिलरली एरिया ऑफ क्रॉस सेक्शन, इफ एनी वायर इज सो थिन, तो रेजिस्टेंस उसमें, अगर एरिया कम हुआ तो रेजिस्टेंस क्या होगी उसमें? ऑब्वियसली ज्यादा हो जाएगी. एरिया ज्यादा है तो रेजिस्टेंस कम हो जाएगा, बिकॉज दे हैव इनवर्सली प्रोपोर्शनल रिलेशनशिप बिटवीन देम. ओके. Resistivity depends upon nature of material and not the geometry dimension of the conductor. So basically resistivity is not depending upon the like shape of conductor, whether it is a square shape or it is cylindrical or what. Resistivity, this rho is the resistivity, and rho resistivity depends upon the material. Okay, material like whether it is conductor, insulator, semiconductor or what. So rho depends upon the material. What is electrical resistivity, तो basically same we are going to learn that resistivity. It is the intrinsic resistance of the material and is the fundamental property of a material. तो कोई material है, कोई object है, like suppose we have a copper, तो copper एक material हुआ, right? Now that copper has some resistivity, राइट कॉपर के पास जो उसकी रेजिस्टिविटी होगी उसी के अकॉर्डिंग हमें पता चलेगा कि उसका कितना रेजिस्टेंस होगा, ठीक है. सो इट मेजर्स द इंट्रिंसिक रेजिस्टेंस ऑफ द मटेरियल एंड इज द फंडामेंटल प्रॉपर्टी ऑफ द मटेरियल. रेजिस्टिविटी ऑल्सो डिपेंड अपॉन टेम्परेचर, टाइप ऑफ मटेरियल, राइट. Resistivity depends upon what? Temperature, type of material, impurities in the material and the physical structure of the material as well. So please remember these are the facts on which the resistivity of a material depends upon. So ये question आपको MCQ में पूछा जा सकता है कि on what factor the resistivity of a material depends upon. So it depends upon temperature, type of material, impurities and the physical structure. Generally metals have very low resistivity, which means they are good conductor. Non-metals have high resistivity, which means they are bad conductor, right? So how to calculate the resistivity? See, R is equal to rho L by A. So rho is equal to what? R A by L. Okay, this is the formula of your resistivity. Now you can also measure the resistivity of a material in the electric field and the current density. So this is also the formula of resistivity if you apply electric field and the current density. So this is the relationship between the resistivity, electric current and current density. ये सारे फॉर्मूले पे क्वेश्चन आते हैं. That's why you have to remember these small formulas, right? Unit of resistivity, ohm meter. Unit of resistance is what? Ohm. Resistance की unit कितनी होगी? What is the unit of resistance? Ohm. Okay. What is the unit of resistivity? Ohm meter. Okay. Ohm meter. Dimension formula M1 L3 T3 A minus 2. These are the list of the resistivity of a material for conductor, semiconductor, insulator. So what you have seen, conductor silver, the resistivity is what? 1.59 into 10 to the power this. Here carbon resistivity 3.5 into 10 to the power minus 5. And for glass it is very high, resistivity is very high, 10 to the power 9 से 14 के बीच में. जिसकी resistivity जितनी ज़्यादा होगी, their conductivity is very less ना. So see, here the resistivity is very less, so conductivity is very high. Resistivity is very high, conductivity is very less. So again the relationship between resistivity and the conductivity is reciprocal or inversely proportional. Now the relationship between all these, see, we know that R is equal to, rho is equal to E by J, J is equal to NE VD. Why? Because J is equal to I by A, so we can calculate like this. Similarly, you have to note down these relationship. Directly with these relationship, you will get questions in your exam. So please note down all these formula. Okay, we are not talking to the derivation part. Just try to write down the formulas here, right? So conductance and conductivity also clear. Conductance is what? Conductance is the reciprocal of resistance. Resistance का reciprocal है, मतलब resistance क्या करते हैं? The flow of current, it resists the flow of current. Conductance क्या करते हैं? करंट का फ्लो कराते हैं. मतलब कोई मटेरियल है, अगर हम कहेंगे कि इसमें कंडक्टेंस ज्यादा है, दैट मीन्स करंट ज्यादा है। अगर हम कहेंगे ये मटेरियल है रेजिस्टेंस ज्यादा है, तो दैट मीन्स करंट कम फ्लो होगा। ठीक है। Conductivity is the reciprocal of resistivity. So here you can write down conductance is the reciprocal of resistance, and the conductivity is what? Conductivity is reciprocal of resistivity. Okay. Now let us understand the temperature dependency of resistance. How the resistance depends upon the temperature, or how the temperature affects the resistance. ठीक है. Now suppose we have a material like metallic conductor. Now we have a conductor which is made up of metals. Okay. When you increase the temperature, so now अगर आपने उस metal पे temperature बढ़ाया, so what happened due to the temperature? अब उसकी जो resistance है वो increase कर जाएगी with temperature. So as you increase the temperature, जैसे जैसे temperature बढ़ाते जाएंगे उसका resistance बढ़ता जाएगा, right? Why resistance increases, guys? Because more atomic vibration, more collision, higher resistance. See, क्या हुआ कि like suppose this is your conductor, okay, ये यहाँ पे सारे इलेक्ट्रॉन्स हैं, जैसे ही आपने इसको टेम्परेचर दिया, अभी इसमें मोबिलिटी बढ़ गई, their electrons are started vibrating, right? And when they started vibrating very fast, they are colliding with each other, and जितना ज्यादा वो कोलाइड करेंगे उनका रिलैक्सेशन टाइम कम हो जाएगा। तो जब कोलाइड करते रहेंगे तो उनका जो फ्लो था एक डायरेक्शन में वो कम हो जाएगा, तो करंट का फ्लो कम हो गया ड्यू टू मोर कोलिजन। अभी कोलिजन हो रहा है ना, वो फ्लो तो नहीं कर रहे, वो टकराए जा रहे हैं, जैसे आगे बढ़ रहे टकरा के उनका डायरेक्शन चेंज हो जा रहा है, जा रहे हैं टकरा रहे हैं कहीं और चले जा रहे हैं। तो ड्यू टू दिस व्हाट हैपन, द रेजिस्टेंस डिक्रीजेस। ठीक है। तो ऑन इंक्रीजिंग टेम्परेचर इन अ मेटेलिक कंडक्टर, टेम्परेचर द रेजिस्टेंस डिक्रीजेस। ओके। इन सेमी कंडक्टर व्हाट हैपन, on increasing temperature the resistance decreases. Why? Because in semiconductor जो current का flow होता है that is due to the electrons and the holes, right? On increasing the temperature the electron from valence band reaches to the conduction band, right? So and create a hole. So जब आप temperature बढ़ाते हैं then only this phenomena takes place. So there the resistance decreases, where in alloys very small change occur here due to use in heating element, that's why. So these are the temperature dependency. Now for metal the formula for resistance temperature RT is equal to R naught 1 plus alpha T, right? R naught 1 plus alpha T. RT is what? Resistant at temperature T. R naught is resistance at the 0 degree Celsius or the reference. Alpha is the temperature coefficient, T is the temperature change. So just note down this formula. With this formula also you will get questions numerical in your exam. See, you have understood the concept ना कि क्या हो रहा है टेम्परेचर बढ़ाने से. Now question में आपको formula याद है, whatever the question they will ask you are able to answer. Okay, now this is what, this is the color code of a carbon resistor. See, actually you know resistance is basically the symbol of resistance is this is the symbol of your resistance. अगर कोई वायर है, अगर कोई डिवाइस है, हाउ डू वी गेट टू नो कि इसमें रेजिस्टेंस कितना है, कौन सा रेजिस्टेंस एंड ऑल है. सो नाउ वी आर यूजिंग द रेजिस्टर. तो अगर हम रेजिस्टर यूज करते हैं, विद द हेल्प ऑफ रेजिस्टर वन कैन नो दैट ओके दिस इज द डिवाइस एंड दिस डिवाइस हैज दिस मच रेजिस्टेंस. तो रेजिस्टर सिंपली रेजिस्टेंस शो करने का एक डिवाइस है, आप कह सकते हैं. ठीक है. नाउ दिस रेजिस्टर इज अगेन मेड अप ऑफ डिफरेंट कलर कोड्स, बिकॉज उस पर रेजिस्टेंस तो नहीं लिखा होगा ना. तो विद द हेल्प ऑफ कलर कोड वन कैन आइडेंटिफाई दैट व्हाट इज द रेजिस्टेंस ऑफ दिस पर्टिकुलर रेजिस्टर. ठीक है. तो अभी जो रेजिस्टर है, दिस इज द रेजिस्टर सपोज, ओके, इट हैज सम कलर कोड. सो इसमें आपको कई सारे रिंग्स दिख रहे होंगे. सो द फर्स्ट 2 रिंग्स फ्रॉम द एंड, इधर से ये जो 2 रिंग है ना, दैट विल टेल्स यू द सिग्निफिकेंट फिगर इन द ओम. सी हियर दीज आर द कलर these are their number, color and the tolerance. So letter also given, you have to remember this. ठीक है, ये आपको याद करना पड़ेगा table. So now suppose this is B, capital letter B, B for black, or you can say just take it brown color. It is brown color ring na, so brown and the violet V. So for B number is brown is 1, for violet 7. So the first two rings shows the significant number. Third ring indicates the decimal multiplier. Now what is this third? Black color. Black color is 0. So 10 to the power 0. Now the last ring indicate the tolerance. Now we have three tolerance: gold, silver and no color. So if it is gold, that means 5% tolerance. So now 17 plus minus 5% tolerance ohm is the answer. Okay. For C here 52, first two is the significant number, then the decimal multiplier, then it is silver, 10% tolerance. So like this resistor has this much ohm. So like that you can create you can get to know that how much resistance do a particular resistor has. Another color code carbon resistor is, this is the another type of resistor where you have a body, two ends and the ring. The color of the body gives you the first significant figure, at the end gives the second significant figure. Decimal multiplier, the color dot, here they have a dot also, dot will give you the decimal multiplier and the ring gives you the tolerance. तो जैसा वो था ना उसके लिए, उसी तरह इसके लिए भी आपको कुछ कोड्स हैं, वही सेम लिस्ट आपको याद करनी पड़ेगी. दिस इज अनदर टाइप ऑफ रेजिस्टर. सो ये जस्ट आपको प्रैक्टिस करना होगा. दिस इज ओनली आफ्टर प्रैक्टिसिंग यू मे गेट. Now series combination and the parallel combination of a resistor. So I hope you all have learned in class 10 as well, right? Series combination में क्या होता है? We are adding the resistor in a series. Like यहाँ पे जो terminal होते हैं इनके, like they are the resistance, one end of the resistance attached to one terminal, other end is attached to another terminal. So this is called the series arrangement. Series arrangement में, now suppose this is volt and the current I is flowing. So current I is same for all resistance, okay, but V is changing. The voltage is, the potential difference is not same for all the resistance. So if you have to calculate the resistance in a series, R is equal to R1 plus R2 plus R3. This is the formula for series. You have to practice numerical with that. Always this capital R is greater than the greatest of all. Okay, for an individual. अगर हम एक इंडिविजुअल रेजिस्टेंस लें और इक्विवेलेंट रेजिस्टेंस लें इन सीरीज, सो ऑलवेज द इक्विवेलेंट रेजिस्टेंस इज ग्रेटर देन. इन पैरेलल व्हाट हैपन? Here you have a V. So now what happened in case of parallel, the current distributed, right? Now we have changes, color 1, I2 and the 3, but voltage is same for all the resistance. So what is the equivalent resistance for this? 1 by R is equal to 1 by R1, 1 by R2 plus 1 by R3. So this is the equivalent resistance of the parallel resistor. Now the sources of EMF, right? What are the sources of EMF? EMF is the electromotive force. Electromotive force is that force due to which the charges started moving. ठीक है, जैसा मैंने कहा था कि भाई चार्ज अपने से तो मूव करेगा नहीं, उसको कुछ चाहिए होगा ना, एनर्जी. सो द इलेक्ट्रोमोटिव फोर्स इज दैट मैक्सिमम पोटेंशियल डिफरेंस बिटवीन द टू इलेक्ट्रोड व्हेन नो करंट इज ड्रॉन फ्रॉम द सेल. What is the difference between EMF and the potential difference? EMF is basically what? EMF is the maximum potential difference between the two electrode of the cell, right? Maximum potential difference between the two electrodes of a cell when no current is drawn, when the circuit is open. Potential difference is the difference of potential between any 2 points closed in a circuit. It is independent of the resistance. It is proportional to the resistance. right? Like potential difference V is proportional to the resistance. The term EMF is used only for the source of EMF. It is measured between any 2 points. It is greater than the potential difference. However, potential difference is greater than EMF. So, these are some of the differences. Now, let us see the internal resistance of a cell. सी इंटरनल रेजिस्टेंस हम क्या देखेंगे, जैसे सपोज करिए कि आपके पास कोई डिवाइस है और वो डिवाइस किसी बैटरी के थ्रू चल रहा है, ठीक है. तो व्हेन यू आर यूजिंग अ बैटरी, जैसे कोई वायर है, उस वायर में करंट फ्लो हो रहा है, तो उस वायर के अंदर भी तो उनका रेजिस्टेंस ऑलरेडी है, दैट वायर हैज इट्स ओन रेजिस्टेंस. Okay, but if you apply a battery, so now that battery has a electrolytic solution within them. उसके अंदर भी तो केमिकल सोल्यूशन होता है बैटरी में, तो बैटरी क्या करती है, केमिकल रिएक्शन चेंजेस इनटू द इलेक्ट्रिकल एनर्जी. सो व्हाट हैपन हियर, ड्यू टू दैट battery, due to that cell, again the wire got some resistance. तो उस बैटरी की वजह से जो रेजिस्टेंस मिलता है, उस इलेक्ट्रोलाइट की वजह से जो रेजिस्टेंस मिलता है, दैट इज द इंटरनल रेजिस्टेंस. Okay, so the opposition offered by electrolyte of the cell to the flow of electric current is the internal resistance. ठीक है, like suppose this is your battery cell, इनका अपना एक internal resistance होगा, EMF होगा, potential होगा. So this is the internal resistance, और ये तो हमारे circuit का resistance है ही. Okay, so small r will be the internal resistance. तो अब इस पूरे का जो EMF हो जाएगा वो क्या हो जाएगा, this potential difference plus इसका potential difference. This is IR, this is small IR. दोनों ही potential difference है, ये पूरे वायर का है, ये बैटरी का है, ठीक है. IR, I common R plus R. So from here what you can calculate, I is equal to E by R plus R. This is the formula for current. Like अगर internal resistance दिया है तो with this formula you can calculate the current. What are the factors which affecting the electrical resistance? Internal resistance is, see, larger the separation between electrode. Now if you have a galvanic cell or if you have a Daniell cell, so in that cell you have a electrodes, now one cathode and one anode you are using, right, and then the electrons are flowing and the current generated. So if the distance between the electrode increases, so as the distance between the two electrode increases, what happened, length increases, then more the length of electrolyte through which the current has flow, consequently higher value of the resistance. R is what, directly proportional to L ना, तो जितना ज्यादा इलेक्ट्रोड के बीच में डिस्टेंस होगा उतना ज्यादा रेजिस्टेंस बढ़ता जाएगा, तो R is directly proportional, तो internal resistance also increases. Greater the conductivity of electrolyte, कंडक्टिविटी कैसे मिलेगी, लाइक सपोज इफ यू हैव अ KCl, तो KCl गिव्स यू K प्लस एंड Cl माइनस इलेक्ट्रोलाइट. तो लाइक दिस, मोर द आयंस दे हैव, मोर द कंडक्टिविटी दे हैव, लेसर द इंटरनल रेजिस्टेंस, राइट. सो जितना ज्यादा आयंस होंगे, मोर द इलेक्ट्रॉन्स, मोर द फ्लो ऑफ इलेक्ट्रॉन, मोर करंट, तो रेजिस्टेंस विल बी लेस. The internal resistance is inversely proportional to the common area dipping in the electrode. So obviously resistance is inversely proportional to area. More the area, less the internal resistance. Internal resistance of a cell depends upon the nature of electrode as well. Okay, so these are some of the factors which affect the internal resistance. Now similarly, when the cells are in a series combination, see, this is your circuit where you have just connected the cells in a series combination, like you have connected resistance, you have connected cells in a series combination. The cells are connected in a series when joined end to end, so that same quantity of electricity must flow through each cell. So I should be same in each cell. Okay, now the EMF of the battery is what, the इस पूरे बैटरी का जो EMF होगा इज सम ऑफ द इंडिविजुअल EMF. The current is same. The total internal resistance of the battery is also the sum of the individual resistance. So total EMF क्या हो जाएगा? NE. N क्या है? Number of identical cell. Total internal resistance NR. Right? Total resistance of the circuit क्या हो जाएगी? इनकी NR and the capital R. Okay. So now what is the current? E by R plus R था N. Now why this N you are using? Like how many cells you are using? 3 cells, तो N will be 3. तो ये N आपने उस चीज के लिए लगाया है, ठीक है. Similarly, when the cells are connected in a parallel, so the EMF of the battery is same, the current divided the reciprocal, or now the reciprocal of internal resistance changes. So now the total EMF of the battery is E. Here the internal resistance become R by N, and the total resistance of the circuit is what? R by N plus R, right? So now the formula is changes. See here is the change only. So this is what will be, what we can say the formula of internal resistance, right, when they are conducted in a series and a parallel. So ये formula you have to remember and you have to practice questions, right? These are some of the like basic conceptual questions, like which tells you like how much you have remember. Conventional current flow from, so conventional current flow from positive to negative terminal. Okay. Next question. Drift velocity of electron depends upon. So drift velocity, thermal velocity due to heat. The electrons flow due to heat. In drift velocity, it depends upon the electric field. On applying an electric field only, the charges moving. Current density. What is current density? J is defined as the current per unit what? Cross section area. Current per unit area. So 3 is the correct answer. The color code of a carbon resistor indicate its resistance value and the tolerance. So color code say you will get the resistance value and the tolerance. Internal resistance of the cell causes the terminal voltage to be. So due to the internal resistance, what happened? The terminal voltage is less than the EMF when current flow. This is a numerical. Try to practice this numerical. Current is given, right? Number of density of electron is given. You have to calculate the drift velocity. So all the value is given. You have to put and you have to find out. Just pause the video and try to find out the answer by yourself only. Okay. Similarly, again we have a cell of EMF 12 volt, internal resistance small r is 1 ohm connected to capital R 5. So यहाँ पे आपको small r दिया है 1 ohm, capital R is 5 ohm and the E is given 12. Find the current. Current क्या था? I is equal to E by R plus R. Simply put the formula, you will get 2 ampere current. Alright. So that's all about your current electricity. I hope you have understood the basic concept related to current electricity. See, this topic is very easy, only and only you have to practice numerical, right? Concept समझ में आ गया क्या होता है current, how the charges are flowing, right? What is current density, what is drift velocity, what is mobility, internal resistance and all. Just connect all those formula, write down. Practice question, as many questions you will practice now, more clear will be your concept. So with this, I am ending this session. Hope you find it well and you have understood all the concept. With this, thank you everyone. Bye bye. Take care.